Okay, so I'm the last speaker. My name is Eva Krumhuber. I'm a psychologist. I typically collaborate with computer scientists. I'm a certified fax coder. Maybe I'm the old-fashioned trained fax. I have actually one of my first postdocs was spending half a year manually fax coding videos. So these are the old times. I had Paul Ekman sitting in the audience when I was a PhD student. That makes me sound really old now. But today's project is about something else. It's about face identity, and we've seen already with the first talks that technology has really propelled amazingly forward with software that can now generate fake faces that look incredibly realistic. So these are just some examples. This person doesn't exist. Website, it generates a new lifelike image every time the page is refreshed, and you can specify the age range, the gender, the ethnicity. Another example is MyHeritage. It uses deepfake technology to animate the faces in photographs of dead relatives. So in 2022, a very prominent paper actually got published in which they used generative adversarial networks to generate AI face images, so synthetic images. And what they did pretty much in their study is that for each AI image, they selected a matching real face that was similar in gender, age, and overall appearance to they selected these faces from a database that consisted of 70,000 images that had been used to train this style gun learning algorithm. And what they found is actually that people were unable to distinguish AI faces from human faces, and specifically for white faces, so for white ethnic faces, real and AI images were the most difficult to distinguish. And the authors speculated that this might be due because white faces are overrepresented in the style gun training set. But they didn't directly test this hypothesis. So we wanted pretty much to test this. And what we did is pretty much we reanalyzed the data from Nightingale and Farid's original study. And we took a random selection of images. So we took 1,046 images from this 70,000 images training data set. To manually verify the demographics such as age and gender. And as you can see here, although there is some diversity in these images, but actually the majority of these images are actually white ethnic faces. So when we separated out in Nightingale and Farid's data, original data, the non-white faces from the white faces, we actually found that for non-white faces, the AI images, you can see here them in purple, the AI images were judged as human at around chance level. And similarly for non-white human images, they were judged as human at around chance level. So there was no significant difference between the two types of images. And to ensure that the data pretty much are robust, we ran a separate study. But you can see here that actually for the, when we actually look at the white faces, we can see that the AI images, they were actually judged as more human than chance, and also as more human than the actual real human faces. So to ensure that these findings are robust, we ran another study with a new set of participants, and we actually found the exact same result. And we call this shift to see AI images as more human than the actual human images. We call this AI hyperrealism. So people pretty much were unable to distinguish between the two faces. That doesn't go forward. So you can see actually the four images that. So you can see that the four images were the four AI images that were misidentified as human most often, they were actually white ethnic faces, and the faces of real people that were misidentified as AI, as computer generated, most often that were actually faces of color. So the big question is, of course, now, so what made these white AI faces appear so hyper real? And besides letting participants decide whether a face is AI or real, we also ask our participants what information they had used to make the judgment of whether a face is real or computer generated. And we then, it was a free response, so they could pretty much write anything that they wanted to write. And we then coded this information into 21 main themes with 20 sub-themes that you can see here. And there are various issues like, for example, did they use image quality? Or for example, they said the coloring looks maybe a bit weird or fake, or maybe the eyes looked not real, they looked like animated, or the background. So there was a variety of information that they had used. And you can see that the thickness of a subsection indicates the frequency with which a particular trait was mentioned. In another study, then, we let new participants rate the AI and real faces on these attributes that you have seen on the previous slides. And what we found is that actually the two types of faces, they really do differ physically. So in fact, AI faces, they are more proportional, they are more average, they are more familiar, symmetrical, attractive, perceived to be alive in the eyes. They have higher image quality and congruent lighting. And AI faces are less memorable and expressive, and that perfectly aligns actually with face-based theory that always suggests that actually the algorithm always goes towards the average, the statistical average of something. So, but actually you can see here actually that the AI face is more proportional than the human face. But the problem is that people expect human faces to be more proportional. So therefore, what they're doing is actually they're misrepresenting these characteristics as a sign of humanness, which then, of course, leads them to incorrectly perceive AI faces as human because they are using the wrong characteristic. So we then also tested actually, this was the Brunswickian lens model where we tested direct and indirect effects. And you can see here pretty much the attributes that contribute to people's judgments of whether a face is AI and humans. And you see here attributes in red. And red, these are pretty much attributes that are used in the wrong direction to judge whether a face is AI or human. So actually human faces are incorrectly perceived to be more proportional, more familiar, and less memorable. And the green attributes, these are attributes that contribute to correct judgments, to correct AI and human differences. And you can see here that this misinterpretation of these characteristics leads to this AI hyperrealism effect, where people are just using the attributes in the wrong direction. As a last question, pretty much, we ask, do people actually have insights into these AI detection errors and that they're actually making so many mistakes? So we pretty much, besides letting participants pretty much judge whether a face is AI or human, we also ask them, how confident are you in your judgment? Or how confident are you that this judgment is actually correct, whether a face is AI or human? And this was a simple scale from 0 to 100. And what you can see here, that for the classification of white human faces, we have a negative relationship, that the more errors people made in their judgments, the less confident they were. But for the classification of white AI faces, we actually see a positive relationship, suggesting that the more errors people made, the more confident they were. So as such, people who performed the worst in distinguishing AI and human faces, they were actually the most confident. And I think this is a quite dangerous, or also very important to know, because most people, or we all, are making a lot of mistakes, a lot of errors, but we have zero insights actually, and we are not aware that we're actually fooled by AI, or fooled by thinking that this person is actually real when it's not real. And I let the implications up to you. We've written up the paper, and I've also a poster that you're very welcome to talk to me. And that's pretty much all for me today. Thank you.
Thank you for the talk. It was very interesting findings. So sounds like AI is just predisposed to produce very high quality images, and people are predisposed to classify high quality images as real, as opposed to AI. And they expect AI images to essentially have artifacts which apparently AI images don't have anymore, or things like lighting variation or makeup or things of that nature, which do happen in real photography, but people don't expect that. I would suspect that AI has nailed the uncanny valley of static appearance. It's the uncanny valley of motion, where people might be able to have a better chance of detecting things. And maybe even that's crossed at this point, given the amount of data available. So it's a hard problem, I have to say.
Yeah, thank you so much. I completely agree, and I think like we have to think of the implications now, because people share private data. They share we have now AI doctors, we have now chatbots where people share. We have counseling chatbots where people share very, very private information with artificial synthetic humans, and the implication is the ethics and the moral implications of that. So there's a lot to come that results from all this amazing technology that we are hearing about today. Yeah.
Thanks, Eva. Cool. I was just wondering, I mean, it might be very difficult to estimate because it's kind of almost done at source now. Like if you take a picture on your phone, it's already being post-processed. So I wondered if you had any estimate in your like test set or training set, what proportion of have the photos been edited, retouched afterwards, after the fact? Are they actually sort of raw photos, or have they all been, like if you're saying it's sort of over smoothed or something like that, is that something that's happened before training? Has that happened before training here? Has it happened before training in the test?
Yeah, we didn't. It's a really good question about this style gunned training set, and it's actually publicly available. So you have access to the 70,000 images that has been used for training this as algorithm. And yes, there might be certain issues, and if we see, we've already seen there are still, problems with respect to ethnicity, not enough diversity in this whole image set, maybe also not enough diversity in the backgrounds and the lighting. And we see people make different judgments just based on different lightings. People make different personality attributions. So there's a lot. We didn't test it because, I'm a psychologist, so we didn't test this technical image-based features in these images. But it relates back to this question of why are people so misguided by information and what they're looking for exactly, and what actually nowadays counts as fake. Where is the boundary on a computational level, on a perceptual level? Yeah, as you say, so is a visual representation, when I take something with a camera where you already have a filter on it, is this actually already a fake image of yourself? Or is it still the real, this boundary, it blurs already at very early stages now, and becomes even earlier. Yeah, thank you.
Cool. Thank you.
So we know in the data set it's got a racial bias towards white people. We also know that subconsciously we have a racial bias towards being able to identify people of the same race as us compared to somebody of a different race. Did you control for that when you're asking these questions about how well somebody, one's an AI or whatever, so what I'm trying to say is that the racial makeup of your participants identifying what was real and what was AI? Yeah,
it's a good question. We try to not step into cross-race effects and out-group homogeneity effects, because we all know we are biased in judging other race faces. So all our participants were pretty much white, ethnic. They had to reside within the US within a certain amount of time. So they were all a homogeneous group of people, because we just tried to exactly eliminate. Because yes, certainly, if you have different ethnicity as well and different nationalities in your perceive and observer group, you also get different you get different ratings, definitely. Yeah, and that's a limitation of our study. But we just wanted to make, at least for one group of participants, a very clear statement in terms of how they are already biased. So yes, obviously, and that's still an issue that most of our participants in experimental studies are still white. We are very, very, the data that we have is very white biased in general. Yeah, thank you.
Oh, sorry, I missed if there was feedback to the participants about the decisions and whether it's correct or not.
We didn't get feedback on the frontal. The original study that was published in PNAS by Nightingale and Farid, they had an accuracy rate in the first study of 48%, which is chance level, and in the second experiment that they did, they gave feedback after each round, and it's not much higher. It's not 59%. So it's not much better. So people don't seem to learn from that feedback because I think they don't know about the cues. And I think that's what we have to do as a community to inform the public about. This is a cue that you have to look forward to, or this is something that you could test, that you could use in your daily life, because we are very naive when it comes to sharing personal data with platforms where we think there's a real human behind, but actually it's not. So yeah.
And would you expect the hyperrealism effect also to survive the feedback? Or like if you gave feedback, would the hyperrealism also remain?
No, as long as you don't know what you're actually doing. So people are just guessing. They're constantly guessing and update their belief systems. It's like the optimism bias, where people get feedback about their chances of getting cancer, and they're getting all the symptoms, and they're constantly updating the feedback. But as long as you don't give them concrete information of what to look for, the learning doesn't take place. So we have to really tell them, this is the feature. AI faces look more average, more attractive. They're idealized, standardized, and this is exactly a feature you should go against. Thank you.
Thanks, Eva.
Thank you.
Interesting talk.